Hello, welcome to numerical ship and offshore hydrodynamics. Today we are going to discuss that we continue from the last class to take the case study to get how to find out the solve the problem of the infinite fluid domain to get the added mass and damping etcetera. You do not get the damping to get the added mass. Okay. So, this is the keyword that we are going to use to get this lecture. Okay. So, now let us continue from where actually we stopped in the last class. So, in the last class we tell that to write a good programming and in order to get the input very correctly, you have to do lot of initial things. You have to check lot of initial things. For example, if you remember, we said that when you do the meshing etcetera. So, this is the ship and when you do the meshing etcetera. So, your input is the meshing. So, therefore, you need to do the quality checking of the mesh before you further proceed, right. And then we have lot of discussion what can go wrong and then what you should avoid, what you check first, everything we have discussed in the last class. Now, today we really start to develop a code and how to write a good efficient code, let us try to discuss today. Now, if you look at this particular problem to find out the added mass in infinite fluid domain using the panel method or the G equal to 1 upon R. So, these are the physical problem we are going to solve. Now, in order to attack this physical problem, in order to write a good code, you have to remember certain basic things. What are those? First, this is some we normally let us set this lecture with respect to some object oriented coding language, right. And also that MATLAB also you can follow the same way. However, normally it is seen that if you try to do a commercial coding, so normally people use C++ or C# something like this or Visual Basics, all are basically object oriented programming language, right. So, and also this type of code what required lot of playing with the data, lot of play with the geometry to set some detailed logic. It is always beneficial to use some language which actually build on some structured language, I would say, like C# or C++. Normally, if we try to write a model for this type of thing, we can call this a MVC model. Now, M itself is a model and V is a view and this is controller or control. Now, what do you mean by model, what is the meaning by the view, what is the meaning by the control? Let us try to explain one by one. Now, model means that for our case the model is the ship data and the physical problem, that is my model. And then, so in M it stands from that my ship data, right, how I write or how I store my ship data. So, this is the first thing, and then how I can view the result, right. Now, how we can I mean it is actually we can see lot of way we can view our result. Somebody wants some graphical way to see that, like I give the ship data and then I need to see the whole ship is coming in front of me. So, somebody can say okay, this is how I can view the data. Somebody wants okay, let us if the user wants, then I can give back their data. Okay. That means, in a mathematical form or in terms of some Excel file or some tabular form, I can give the data. So, then so view is one aspect, like the data how we can show to the user, okay, the end user, and then these two actually we control through the point controller, or you can call it C. Okay. So, now let us try to for this particular problem, let us start from the basic, that for M how I keep the model, and then how I control it, and finally, how I can view this. So, let us do step by step. Okay. Now, the first part, that how I write the data, that we discussed in the last class. Now, let us now try to solve the problem using that data. So, at end of the everything, what we have right now is basically the elements or the panels. If you remember what I said in the last class, suppose I have this the shape. So, the final we stop at this point, that we have some panel or triangular or quadrilateral mesh, and also we understand that we have to find out if the normal are outward drawn normal or inward drawn normal. Now, how to make sure the data should be uniformly, the normal should be uniform outward drawn or inward drawn, that we are going to discuss now. So, let us first try to solve that M part, that is the model part or data part, how we are going to take it. Now, see here, if you look at this coordinate system, now here x is positive and then here the x is negative. Now, let us take the transverse axis, that means the y axis. So, this is your x axis, now this is your y axis. So, this side is positive, let us say this side is negative, okay. And then you have this the z axis. Now, in z axis the upward is positive and then this downward is negative. Okay. So, now I have, now I understand, then I have, let us say, draw this three system, this side x is positive, this side y is positive, or and this side the z is positive. So, let us say z of vertical side. Okay. So, let us change it, let call it z and let us call it y. So, now if you draw the shape and let us make sure that I need that outward drawn normal should be inward to the fluid. Then what I need to do is, now if this is my paneling and if you take the middle part is x equal to 0, this side is let us say plus x and this side is minus x, then I should take the meshing should be in this form. So, I said that my meshing should be here anti-clockwise. So, if it is the point number 1, it should be the point number 2, this should be the point number 3 and this should be the point number 4. So, if you do that, then it is always the normal should be the outward to the body, inward to the fluid. Now, in other side, so now if this side I try to make, so this is the side when y is negative. Now, when here this side is y is negative. Okay. Now, suppose where the y is positive, that means the other side of the vessel, how I can orient the number 1, 2, 3, 4. Now, in that case you have to go clockwise. So, it should be 1, then it should be 2, this should be 3 and this should be 4. Get it? So, now in this side where y is negative, I must go in anti-clockwise direction to get the normal outward to the body, inward to the fluid. In other situation, I should go in the clockwise to get the normal outward to the body, inward to the fluid. So, this is how I should do my meshing. Now, this part is done. Okay. Now, let us see that how I can write the formal code. Now, you see, now if you write the equation in summation form, it should be alpha p into phi p is equal to summation I is equal to 1 to n, and then okay, let us take j equal to 1 to n, and then j not equal to I, right, and then first part is phi j and then del n j into r I j. So, this is the first part into d s j. So, this is the first part of the thing, and then it is minus sum over j is equal to 1 to n, and then j not equal to I, and here it is 1 upon r I j into n j into d s j. So, this is, so you have now two things, right. Now, this part we call as influence matrix. So, in this influence matrix, what are the terms? So, I call this influence matrix as A I j. Now, if you remember, I said I not equal to j. Now, what is happening? This influence matrix should come in the left hand side, and then this will at the end I will get a square matrix which is A I j, which is of course n cross n matrix, and with this I have the matrix for phi, which is phi 1 etcetera phi n. So, this also should be n cross 1 matrix, right. So, therefore, the second part I need to get this influence matrix, right. Then how I could get this influence matrix? Remember, I said when I equal to j, then we do not have to do the integration. So, then this is how this matrix, let us call it A. So, this matrix is look like this way. The first point for the phi 1, it should be the alpha 1, I call it the alpha 1 because for I equal to 1, and then it is A 1 2, and in this way it will go A 1 n. Then it is A 2 1, and I call this as alpha 2, and then it is A 2 n, and in that way it is going, and finally, it is A n 1, and then it is alpha n. So, this is how I should write my A I j matrix. Now, when I equal to j, it is called is alpha I, and now this alpha I in our case we should take this minus 2 pi. Okay. So, how I get this minus 2 pi, we are definitely going to discuss this, but if you remember, in fact, in our previous lecture, if you remember that we have 4 pi phi is equal to minus 4 pi phi is equal to, I have this integral equation which called this over the S body, and it is phi into del n 1 upon r minus 1 upon r into del phi del n into ds. So, from this equation actually and then I replace this by solid angle which is alpha. Now, when I equal to j, this value of alpha becomes minus 2 pi. So, when we are going to discuss this later on, when we actually do this Wamet type solution or the panel method for frequency domain panel method for floating bodies, we are going to discuss that part. That time we come to know how this value comes as minus 2 pi, but for the time being let us take this as I said, when I equal to j, the matrix entry should be minus 2 pi. So, therefore, this entry now becomes always when I equal to j, the value should be minus 2 pi. Okay. And then when I not equal to j, then I have to do this a I j part, right. So, now I understand, now I first I need to write my influence matrix. Now, I understand that when I equal to j, thus entry a I j should be is equal to minus 2 pi, and when I not equal to j, that time my entry should be, as you know, it is del del n into 1 upon r I j, and if you remember we have solved it, this is nothing but r into r I j dot n j divided by mod of r I j cube, right, that we have already discussed. Now, see, now this actually tell me that how to write the influence matrix. Now, here comes the coding. Now, we know that how to get this get this value of this, but how to arrange it in a code, so that when now thing is that you write a code and then maybe somebody wants to develop the code based on that what you have written, but then he should understand your code. So, your code should be logical, right, and it should be understandable to the other person, right. So, in this case, that how actually we proceed. Now, you see that if you do in the object oriented programming. So, now in order to write this code very efficiently, now in object oriented programming language, some concept is called the primitive class. Now, what is primitive class? Now, this is the class, it is something called the most basic class, where your input is minimum and then output is minimum. Now, when you say that input is minimum and what you call the output is minimum, what is the meaning of that? Now, you see, suppose you want to perform this equation to get this a I j this coefficient, then you have to do at some point some a I j is you need to do this operation, which is r I j multiplied by n j divided by mod of r I j whole cube, and of course, you need to multiply with this the area associated with this, right. So, this you need to do, you see it is not a single task. Now, if you break it stepwise, then what is the r I j? It is the distance between the source point and the field point. So, this nothing but your x I minus x j, right, I plus y I minus y j into j plus z I minus z j into k. This is something you have to calculate this r I j first, and then you need to calculate the second thing, which is the normal, right. So, normal also have some 3 component n x into I plus n y into j plus n z into k, and then you have to do the dot product. So, dot product is r I j dot n j, which is nothing but x I minus x j into n x plus y I minus y j into n y plus z I minus z j into n z. So many operation you are doing, and then finally, you have to do this mod of r I j cube, which is nothing but it is x I minus x j square plus y I minus y j square plus z I minus z j square and whole to the power 3 by 2. So many things you need to do. Now, if you write everything inside a single code, then you are in trouble, because when you do all such thing, at the end if you get something wrong, your program is not running correctly, then you really do not know at which steps actually you are making mistakes. So, in respect to avoid this, we have to write some primitive class. Now, here how do I write the primitive class? Here I could write some primitive class. So, first I can write one class which is called panel. Okay. And then in this panel actually I can define some property of a panel. Now, how do I define a property of a panel? So, one panel is, you know, that it should be the coordinate of the 4 point. So, the property number 1, inside this I can put the the corner point. So, this is number 1. Second one is also I want to find out the area. So, second property I can find out the area, right, and then the third property I can find out the normal of the panel, outer normal to the panel. So, this is the 3 property actually, and also fourth one of course I forgot, which is the center of gravity, or we can call as CG. So, you see that this 4 is essential for a panel. So, I define this. Now, here this normal also not primitive. Now, this is normal is nothing but a vector. So, I can take another class which is called the vector. Then in this vector class you can have that, in order to draw the vector you need a start point and the end point. So, in this vector you can have something called the start point and something called end point, right. And also once you draw the vector, so you have to write some primitive, some function, some normal primitive function. What are the function? For example, dot product, because you have to do the dot product if you remember. So, I am writing dot product. I need to find out the area. So, I need to write a function, it is called the primitive function, which is called the cross product, right, fine. So, you see that I just make one class vector, but it again requires some points. So, I need to write another primitive function or another primitive class we can call as point. In this point what you have? In this point you can have some function which is double x, double y and double z. Now, this point actually called the most primitive class, which only having the basic thing, the double integer. So, now any class that you are dealing with the double and integer, it is called the primitive class. Okay. Now, you see how we can break this interface matrix in using these primitive classes. So, First thing you need, you have to write, and this logic, you see you have the two part, one is called the core, which based on your geometry, you are doing the integration, you need doing the differentiation, all these things is the core engine class. Another is called the business logic, where actually you are writing the basic logic of the program. Now, let us see how I can write this influence matrix with the help of these three primitive class, I would say. Now, see again in my business logic, when you call this, it is my how I write it. Now, suppose this class is you can again call a function. So, you can call it the influence matrix. Now, in this influence matrix, you can write this, let us say I equal to, let us say some 1 to n, something like this. I am just writing the business logic. Say it should be end I, and then you are writing another, and then when you see this, then you have to, now I have introduced my panel, right. So, then I can call some panel P is nothing but I am taking, it is nothing but my from my panel list. So, I have the list of panel, which is your mesh. So, I am taking the panel I, ith number of panel. Okay. So, now again my logic says j equal to 1 to n, and using here the end of j, and then your business logic starts over here. If I equal to j, so your matrix entry A I j equal to minus 2 pi, and else, now here this is the thing, else then you call A I j, and you can write this equal to some function, let us, we can call it get coefficient, and then you are sending your panel I, which is the source point basically. So, you can finding out the panel I, and source point basically your the centroid. So, I am sending the panel I, and then actually I am sending the panel j. Okay. So, panel, make it panel j. Now, you see this is your business logic end. So, you see here, now if you read this program, anybody if he reads this program, he understand very easily that when I equal to j, I am getting minus 2 pi I something, and when I not equal to j, I am calling a function which gives me that coefficient. So, here I am not doing anything, all this core logic which actually involve here, this I am not doing here, right. I am not doing here. So, what I am doing here, I am writing the business logic. So, then now my job is to write the get coefficient a function separately. Now, when you write this get coefficient function separately, there that is also you need to break this function, that get coef. So, this function also, now I just break it here. Here I can get it the 2 point, one is some point which is my the source point, right. I can call it a source point, and also I am sending a panel j. So, this is, if you remember my base class, so base class have this panel j. Now, what is the information this panel j is having? This panel j is having the coordinate, this panel j is having the area of this panel, this panel j is having the normal of this panel, that information this is having, and also it has panel C g, all this information this panel is having. Now, therefore, in get coefficient here your work become very easy. So, now you define your R I j, and actually here also you can, in fact better here if you actually introduce some vector. So, you can use some vector because you have defined your class vector also. So, you can introduce a vector v equal to, and this 3 component is nothing but x I minus x j comma y I minus y j, and then it is z I minus z j, right. Now, you see everything is now very easy. Now, in here the running vector logic is really easy. Now, this r dot n, this r dot n now is a simple one function already I have written in my primitive vector class, which is nothing but the dot product. So, you write dot product and then you can call it is, you are sending the vector v and also you are sending the panel normal. And also here you can call is the is a numerator, or you can call is n, and again or num whatever that base, whatever variable you can take is a dummy variable, or denominator also you can call as. Now, again you can write a function, right, you can write that get denominator and then you are sending your vector v, that is it. So, when you send the vector v and then you are writing a separate function for the denominator, which is get denominator here. Okay. I think let me write in little bit bigger way. So, just because these are all are the small functions. So, in denominator you are writing get denominator. So, you are getting the denominator, and then finally, you can write your the value is nothing but your numerator divided by your denominator and then multiply by the area, this panel area always with you. So, you can multiply by panel area, right. So, you are having your get coefficient, again you coming back over here, see in this get coefficient you are getting the value of A I j. See, now see I am just taking this influence matrix to show you how we can write the matrix A I j or influence matrix. So, you see that in your case, now again so in your case now your A I j matrix or A matrix, now you know how to write it. So, in similar way try to think how we can write the right hand side matrix, which is nothing but your this B I, this coefficient is nothing but summation I equal to 1 to or sorry j is equal to 1 to n, and when j not equal to I, which is 1 upon r I j multiply by n j into d s j, right. Similar way you need to write the right hand side matrix also. Here also you break this thing in small function. Now, you see here also you have this what you need over here. See here also you can write, if you write the business logic here, which is again I equal to 1 to n, right, and then it is end of I. Similarly, you have j equal to 1 to n and you have end of j. Now, here your logic, if I is equal to j, you have to ignore, right. So, you have to ignore it, and else if I not equal to j, then you set your B I, again write a function which is get value something like this. Here you can send your that panel I C G. So, the center of the panel I, right, and also you need to send the panel J, and then this plus your well you can call this as, because you have to, it is a summation. So, you have to say sum equal to this value plus sum, and here each time you make your sum equal to 0, right. So, because you when you enter here the sum equal to 0, and then it is for all j it will get a value, and before it is end of I you can call your b I equal to sum, and then you can write your end of I. So, here also you are writing the get value. Now, get value you write a separate function which tells you this multiplication between 1 upon R I j into N j into d S j, that performance you do there. So, now with this you that whole that coding you are actually split into small function with respect to some primitive classes like points, like vector, like panel. With help of these small classes you can actually write a very good program. Now, once this is ready, once it is ready, you have your influence matrix A, you have your the right hand side matrix the small b. So, then you can just a single line the phi equal to A inverse into B gives you the value for phi, right. So, now once you have the phi, then you are ready to get the value for added mass. Okay. So, we are going to stop here. So, in the next class what I am going to show you, I am going to show you a object oriented programming, where actually I make all these small classes. I will show you how I arrange this class, and then how I do the business logic, and finally, how I get the results. So, these things we are going to discuss in the next class. Okay. Till then, thank you.